In this video, we are going to continue our study of trig, focusing specifically on right triangles. So here's a right triangle. You probably remember from geometry, the right triangle has that right angle in the corner. And we need to remember this is called a leg. This is called a leg. And then this one that's across from the right angle, that's called the hypotenuse. So here's our right triangle. What I want you guys to do on your paper, I want you to circle angle A. And then I want you to draw an arrow to the side that is across from angle A. All right, we call that side the opposite side. And I have it written here so that you can spell it. There's the opposite side. Usually when we do that in trigonometry, we just abbreviate it OPP for opposite. So there's the opposite side. And then we already said the side across from the right angle, that's the hypotenuse. And I've got it spelled right there if you need to see it. And again, just for ease, for making it shorter, we usually abbreviate that HYOP. So that's the one that's across from the right angle. And then this last side here, this one is next to A. That one's next to A also, but that one's the hypotenuse. So this one that's next to A that's not the hypotenuse, we call that one the adjacent side. You guys might remember from English that adjacent just means next to, opposite means across from. So we're using some vocabulary that you might be familiar with. And we're going to label this one ADJ, ADJ for adjacent. So the side across from the angle is the opposite. The side next to the angle that's not the hypotenuse is the adjacent. And then the side across from the right angle is the hypotenuse. Okay, now let's do that whole thing again, only this time we're going to focus on B. All right, so let's circle B. Draw your arrow. Okay, so that tells me that the side opposite B is here. The hypotenuse is here, still across from the right angle. And then the one that's next to B, that's not the hypotenuse, that's this one, that's the adjacent. Okay, one thing I want you to notice about our triangle here is that always the capital letters stand for angles and the lowercase letters stand for sides. And then notice that the capital A is across from the lowercase a, the capital C across from the lowercase c, and the capital B across from the lowercase b. So when we label our triangles, this is the way we're going to label them. Capital letters on the angles, the capital letter and the lowercase letter across from one another, and lowercase letters on the sides. All right, you might remember this phrase from geometry, SOHCAHTOA, and if you pronounce it properly, it will help you a lot. So don't say SOHCAHTOA, right? SOHCAH, those sound the same. I need it to be SOHCAHTOA so that those sound different from one another. All right, and let's remember what those stand for. All right, so S-O-H, that stands for sine, opposite, hypotenuse. Okay, so pause the video just a second, write that on your paper. All right, and then let's look down here at our triangle. Angle A, opposite angle A is side A, and then the hypotenuse here is C. So the sine of angle A is A over C, opposite over hypotenuse. All right, now look at B. You probably noticed in the last one that the opposite for B and the opposite for A are not the same as each other. And the same thing, the adjacent for B and the adjacent for A are not the same as each other. So when I look at angle B and I want to do the opposite that one, well, here it is over here. So opposite of that one is B, and the hypotenuse doesn't change. The hypotenuse is across from that right angle, so B over C. All right, the next one, CAH, CA. What that stands for is cosine adjacent hypotenuse. C for cosine, A for adjacent, H for hypotenuse. So pause the video, write that down. All right, now let's figure out what those things are. So for A, the adjacent side to A, the one that's next to A but not the hypotenuse, that's B. And cosine is adjacent over hypotenuse, so C in the denominator. All right, and now let's look at B. So the adjacent side to B, the one that's next to B but not the hypotenuse, that's this one. So there's A. And then the hypotenuse, still C. Okay, so because the adjacent side changes depending on which angle you're looking at. The cosine of these two angles are different from one another. All right, the next one we want to look at, this last one right here, TOA. All right, that one stands for tangent, T for tangent, opposite, and adjacent. So tangent is opposite over adjacent. Okay, so let's look at that for angle A. Angle A is here. Opposite is across from. That's going to be A. And adjacent, that's the one that's next to it, but not the hypotenuse. That's here. That's B. All right, now let's do B. Opposite over adjacent for tangent. So opposite is across from, which is going to be B. And adjacent, which is next to but not the hypotenuse, that's this one. So that's going to be A. So there's the tangent of A and the tangent of B. So this phrase, if you will memorize this phrase, it'll help you with all of your trig functions. SOHCAHTOA. SOHCAHTOA, which stands for sine opposite over hypotenuse, that's that ratio. Cosine adjacent over hypotenuse, that's that ratio. And tangent opposite over adjacent, that's this ratio. Okay, let's look at that with some numbers. So suppose I have a triangle like this. And it is a right triangle, but we didn't mark the right angle, so let's do that really quickly. There's our right angle right there. Okay, so now let's find the cosine of angle A. All right, so I'm going to go to angle A, which is here. And then I remember my phrase, SOHCAHTOA, CAH, that's adjacent over hypotenuse. So I'm going to go to angle A. Adjacent side is 4. And the hypotenuse, that's the one across from the right angle. So here's my right angle. This time my right angle is at B. And so the hypotenuse is there. It's number 5. All right, so if Delta Math asks you for a ratio, this is what it's looking for. A ratio, remember, is a comparison of two numbers by division. Basically, it's a fraction. So that's the answer that it's looking for. Okay, so now let's go to tangent of C. Okay, so think about your little phrase, TOA, tangent, TOA. Opposite over adjacent. So let's look at angle C. Opposite angle C, the one across from angle C, is 4. All right, so that's the O for opposite. And now A for adjacent. Adjacent next to but not the hypotenuse, that's this one. So the adjacent there is going to be 3. So the tangent of angle C is 4 over 3. And again, if the directions say to find a ratio, that's the kind of answer that it's looking for. Okay, let's do the sine of angle C. All right, so sine, SOHCAHTOA. Sine is opposite over hypotenuse. So I'm going to go to angle C, which is here. The opposite is 4. And the hypotenuse across from the right angle, oops, I accidentally erased my little right angle mark. The hypotenuse is here, and that is going to be 5. Okay, so the directions might say to give a fraction, or it might say to give a decimal. So if it says to give a decimal, you'll just type it in your calculator. 4 divided by 5 equals. And so the answer to that one would be 0.8. Then that's what you would type into the computer if it asks you for a decimal. Okay, let's do tangent of A. So come back up here. Tangent, TOA. All right, so tangent is opposite over adjacent. So I'm going to go to angle A. Opposite is here. That's 3. Adjacent, next to but not the hypotenuse. That's this one. That's 4. Okay, so again, if the directions say to give a decimal, I'll just type this in my calculator. 3 divided by 4. All right, and then there's my answer, 0.75. Okay, so if the directions ask for a ratio, you give this. If the directions ask for a decimal, you give this. All right, let's try that again. All right, let's do this one. In this one, it's set up a little bit differently. You can see they've told me that angle U is 90 degrees. All right, there's the little right angle mark. All right, see if you can remember this notation from geometry. UW, when two letters are written next to each other like that, so here's angle U, here's angle W. And UW means the distance from U to W. It's basically telling you the length of this side right here is 5. So let's put a 5 on it. And WV is 13. Okay, that's here. So let's put a 13 on that. All right, now let's see if we can answer our questions. So cosine, so katoa, cosine, oops, my little H didn't turn out very well. There we go. Cosine is adjacent over hypotenuse. Okay, so let's find angle V, which is here. And the adjacent side next to, but not the hypotenuse, ooh, we don't have a number there. So first thing we're going to have to do is find a value to go here. So think back to geometry when you have a right triangle, and this only works for right triangles. When you have a right triangle, if a side is missing, you can use the Pythagorean theorem. You remember that? Leg squared plus leg squared equals hypotenuse squared. So we don't know what this one is. Let's call it W, right? Because it's across from angle W. So a good choice for that would be lowercase w. So leg squared plus leg squared equals hypotenuse squared. All right, let's work that out. 5 squared is 25, 5 times 5. 13 squared, 13 times 13, 169. Subtract 25 from both sides. So W squared, 144. All right, and to get rid of the square, we talked about this earlier, the opposite of square is square root. Squared and square root cancel out, they're opposites of one another. So W is 12. The square root of 144 is 12. 12 times 12 is 144. So I'll put a little equals 12 right here. Okay, so now we can type it in and we can, not type it in, now we can figure out what it is. Cosine is adjacent over hypotenuse. So here's angle V. Adjacent is the one that's next to but not the hypotenuse. That's 12. And then the hypotenuse, the one that's across from the right angle, in this case, is 13. So I've got 12 over 13. Okay, let's type out in our calculator. So I've got 12 divided by 13. All right, now the computer is not going to ask me to type in this whole number. It's going to ask me probably to round maybe to the hundredths place. So the tenths, hundredths, thousandths, here's the hundredths place right here. And if I want to round to that one, I look at the one right behind it. The 3 tells the 2 to stay the same. So what I'm going to write is that this is approximately equal to 0.92. I doubt the computer wants you to type in the approximately. It probably just wants 0.92 or 0.92 is the same. But I'm just putting that there to emphasize that 12 over 13 is not exactly equal to 0.92. We rounded it to 0.92. Okay, let's do this one. Let's do tangent of W. Okay, so the ratio for tangent, think back. TOA. Tangent is opposite over adjacent. So I'm going to go to angle W, which is here. Opposite is going to be 12. And adjacent, the one that is next to but not the hypotenuse, that's here, 12 over 5. Okay, so there's the ratio. And if we want a decimal, we'll just type that in our calculators. 12 divided by 5, 2.4. So the ratio for tangent is 12 over 5, and the decimal that goes with that is 2.4.